Hello, everyone. Hey, Linux. Nice to see you again. Yeah, so for this week's live, I'm gonna do a quick recap of. Oh, by the way, let me know if the mic doesn't work. Yeah. So for this week, I am going to do a recap of last week. What is RAG? And also, I'm gonna show you some real life example. I have some example with embedding and also some simple example with RAG. And let's begin with a recap of last week. Oh, thanks. Yeah, so a quick recap that RAG is like 3 important component. Let me put on my pen. Okay. So, okay, yeah, it works. Yeah, so there's 3 very important components of RAG, and the first is embedding, and then the vector search. And a quick recap of what is embedding. Embedding, so in this example, you can see there are food information here. We're trying to represent we're trying to describe the food information here with numeric representation, which are embedding. In this scenario, we're trying to describe food with desertness, savoriness, and liquidness. So we are able to describe the food information in this embedding space. So what does it look like in real life application? I'm going to show you example here. By the way, if you're interested in get to play, if you want to play around with this notebook, you can join Discord. I can share the link with you. So this is example of embedding visualization. So we are trying to get embedding of a data set. I want to show you the key step to get embedding. In this example is we're using the sentence transformer model to get embedding. Let me open this. Okay. Here. So what does this model mean? What does this model do is it's basically generate the embedding for text information. It's generate embedding for text data. So basically we have this text information, and once we using this model, we fed into the model and we're able to get the embedding of that text or image or video information. So in this quick example is we having this data. I'm gonna open this again. So we having this. Oh, okay. We having this fetch 220 newsletter news group data, and we're trying to get embedding representation of them. So okay, guess trying to scroll down, and we do some data. We did some data cleaning, and then we're trying to eventually this is so we get the representation of this table here. So this is a what does it look like for this data set? And eventually we are trying to generate this embedding. And this is visualization of basically we're trying to plot the point in this using this library to see. And you can see that when we're trying to generate the data, or we're trying to visualize the data, the similar data are getting close to each other, and the data that are not the same category, they're kind of far away from each other. So this is like a simple example of a visualization, like a visualization of embedding for information. And I can show you the information in this RAG application. So first of all, in this RAG application, oh, I think you're trying to type Discord. Let me share the invitation link to you. I'm going to open the dataset first. I will zoom in. I promise you I will zoom in. But before that, let me try to find the invitation link. Okay. So this is the Discord link. Victoria, I saw you're trying to type in. Yeah, so this is a very basic example of RAG application. And sorry, I need to quick recap. So come back to the component of RAG. We have embedding, we have vector search, we have LLM. So RAG basically introduced information retrieval feature to standalone LLM application. And what it do is it try to get an embedding. It try to generate the embedding of the query item, and in the embedding space, and try to find the K item that kind of close, like physically close to the query item, and then you generate the K candidate item. So they're like in this embedding space, they're actually close to the query item. So that's the candidate item that actually have the that actually similar to the query item. And I'm going to show you how does it look like in real life application, that how we do the query, how we do this, how we find the K closest the similar item to this query item, how we generate the embedding. So previously, we get a quick look of how we're using the sentence transformer to get the embedding of the item. And for this example, I'm going to show you how we generate this embedding space from a data set. And then in this data set, how we find how we do the query item and get an embedding of the query item, and then generate the result by doing this vector search on this RAG. So I will go to this data set first. Okay, so in this data set, it's basically about some line information. And we have this name category, different kind of wine. And we have region, so where this wine coming from. We have variety, rating, and notes. So there are 4 category. Oh no, 5. To describe the wine data. So this is a large, not sure if it's large. It's a not small, relatively large data set. Okay, so this is the data set. And first we want to do is we want to generate the embedding. We want to put this data set to the embedding space. What does it mean? So here we have this embedding space, and it contains all the information. We have the embedding representation for each information, and in this space we have all the embedding in this space. And we want to generate an embedding, like basically we want to put an embedding for all the text information here. And let me see if I can open it. Okay, I cannot. Yeah. So basically, we want to generate embedding for each text information here, and then we put them all in the embedding space, just like just look like this space. And I'm going to show you in the code. So the first of all, I'll have this CSV file. I'm trying to open the drawing pad. Okay. Okay. Oh my god. Okay. I guess it's lagging. Okay. I'll just use and just zoom in then. So this is the data set you just saw, the related. Okay, I think my iPad is a little lagging. Yeah. So yeah, this is a data set you just saw with the wine information. I'm sorry for the. Okay, I'm gonna stop. Let's see if I can open this. Interesting. Okay, I guess let me refresh it to see if I can open the drawing pad. Okay, I can't open it here. I don't know why. Whatever. Yeah, so this is the data set we just saw before. And first of all, we're trying to put them to the dictionary and with the record format so that we can see here a dictionary of the information we just saw. This is basically the information we saw over here. So that's how the first step, we're trying to put that using pandas with dictionary. And then we're trying to use, so in this example, we're using Quadrant client and transformer. So transformer is to, the example I showed you before, to get embedding for the information. And Quadrant is trying to have that embedding space. And I already run this. Like later on, I can share my screen to run this in real time, but I just want to show you the result in case the live demo doesn't work. Oh, hello, Mumu. Thanks for coming. All right, finally, I got it. So this is a Quadrant client, and this is a sentence transformer. I really want to open this. Oh, okay, I guess I find it. Yes. So, oh, okay. I realize that if I zoom in, this screen thing doesn't work. Apologize. Yeah. Okay. So again, this is encoder. Sentence transformer is the model trying to generate the embedding. And we have this Quadrant to create a vector database client. So this is what we are doing. Oh, yeah. So what we're trying to do is this Quadrant client is trying to generate this vector DB client so that we can contain all the information here. I'm gonna go back. Oh, okay. This is not very smooth. And here we try to upload the points here to the Quadrant, and we're able to just do the search. All right, I think my iPad is not running very smooth. I'm gonna try to share my screen on my computer. But you can take a look at this example while I'm trying to open the Colab on my laptop. Okay, I open it in my laptop. Let me try share screen again. Here. Okay. Oh, okay. I think it's better. Trying to see if you can see the screen clearly. Let me know if you cannot see the screen, okay? Hey, Doc. Thanks for coming. Okay. Okay, this is much better. Yeah, so you already saw the data set I show you. And again, just quick recap. This is, we have pandas to, we try using pandas so that we can put the data set to this dictionary. And you can see we have this result over here. And later on, we try to install the quadrant and transformer. Transformer is trying to get the embedding of that information. Quadrant is trying to store all the information in that vector database. So here, we're using this all mini LM L6 V2 model to create embedding. You can also try use different model. This is just an example. And here we're trying to create in-memory quadrant instance so that when we create a collection to store them. So this collection is what you showed before, the embedding space. We name this with the top line, and we put, this is the vector config. If you're curious about why we're doing vector, so basic vector here is just the embedding, and then we're trying to capture the meaning with embedding. So that's why we're using vector to store the book information. And once we have all the embedding, we're trying to upload the points by put this we're trying to generate the encode of them and assign it to this vector here, and so that we can generate this result. So we are asking this question, 99 point carbonate serving, how to say it? I don't know, from Napa Valley, and we are able to generate the result. I can run this in real time and see. You watched the previous lecture but have limited knowledge of Python. Oh, yeah. So when you say you have limited Python, do you mean by you cannot understand the language here, or can you share more about what you're confused? Yeah, so I will share this in Discord after our live event today. So here, I put all the data set in this Google Drive. So I'm trying to download this. And you can see I download this CSV file here. This is a file I showed you previously on my iPad. And then I'm trying to use pandas to read the information. And then I try to install Quadrant client and transformer. And be able to import a client from Quotient client and sentence transformer from sentence transformer. Oh, it took a while, isn't it? While it's running, we can, okay, great. So this is the model we're using. If you're curious, you can just search for this model to get to know better about what does the Hugging Face do here. And here we're trying to create a new vector database, and we put the it's deprecated, and we put the embedding here. So here we do vectorize. Basically, we try. So in this way, the top line information it's encoded from the text CSV information here to the embedding, and we are putting this embedding to this Quotient in-memory client, and then later on we can do the search. So this is a very simple and easy demonstration of a simple RAG. It's gonna take a little while. I'm not sure if this makes sense. While we're waiting, I'm trying to open another example on my end. Yeah, great. Thanks for sharing your thoughts. Okay, it's gonna take a while. I'm trying to open another example here. Oh, I'm sorry, Zach. I think Nightbot gave you some. I also want to show you another example that's slightly complicated compared to this example. Which is from the Google Generative AI repo. I'm gonna share my screen really soon. Okay, coming back to this. Let's try to search. Oh, I'm running this to get the result. So this is the result I showed you previously. Here I didn't connect my key here because I'm sharing the screen, so I'm not gonna put my key here. Okay, so I will stop sharing, and later on I can show you the instruction. Again, I can send you the newsletter and put it in the Discord that how you can do it without using the OpenAI model. You can download the model and run the server locally. So while I'm waiting, I'm going to share another example here. So this is, you can play around with this example at Google Cloud Generative AI repo. So it gives you a really good explanation of everything, and you're able to learn how to use BigQuery and to do the Vortex AI vector search here. So previously, the example I show you is with Quadrant. Here we are doing things with Vortex AI vector search BigQuery with cloud storage, so it's more scalable. But you cannot connect to your building account if you have to using this Google Cloud. So I can give you a walkthrough of this example. I also run this example in my Colab too. So I can walk through this example as well. And so first of all, this is a quick recap of we're searching with embedding. So we're searching by text. We basically generate the embedding of the query text information. And for the searching result, it's basically it's getting the closest points to this embedding. And this is a result. So this is a quick demo and recap of what is RAG and what is vector search do. And again, this is a quick recap of what is embedding. So here it shows you in the embedding space, you're able to generate embedding from content. And the point sets, can you see my mouse? I'm trying to see. Oh, okay, you can. Great. So the points that's close to each other are similar meaning, like what we said before. Okay, I will go to the coding part. So for this example, you need to enable some API for compute engines. I can show you later on in my workspace, but let's go to the flow. So again, what we're trying to do is trying to using this Stack Overflow public data set. And basically, it's all the information in the Stack Overflow. This is what we're trying to, so in this example, we're asking a question, how to shuffle rows in SQL. So those are all the results from Stack Overflow. And so basically, we're trying to implement how we are doing this in with BigQuery. So here are all the information from Stack Overflow. That's why we're trying to, we're using the Stack Overflow dataset first. So we're using data, we've been using this dataset. And so in this example, we're not using the sentence transformer model. We're using a different model from Vortex AI. It is text embedding 004. You can try different model by taking a look at the model and see. So I don't see, so this step is basically generate the embedding from those. So we generate the model so that later on we can feed the text information to this model and generate the embedding from for the text information. Similarly, previously we have the sentence transformer, and we get the embedding for all the line information. And here we're using a different model from Vortex AI, and this is just the name of a different model. And it's a pre-trained model that can translate text information to embedding. We're also able to generate the embedding of other type of data. So that is multimodal search, but I guess we're not deep dive into the text embedding in this example. So here are some helper function, and I'm trying to do the embedding wrapper. So here is a theory of how do we get the embedding similarity. Previously, we only talk about the distance. So in the embedding space, how close they are represent how similar they are to each other. But from some research, you can also do cosine similarity and inner product similarity. They're just different way to calculate how similar two things are. And so how we do the vector search is we trying to calculate how similar, so we have a query item and we have all the points, and we're trying to calculate the similarity either with distance, with cosine, with inner product, and then we kind of sort them so that we can find the k closest points to this query item. And that's why we're trying to sort and print the question by similarity. So that is generally how vector search work is. You're trying to figure out similarity with a certain way, and then you kind of sort by how close they are in this embedding space, so that represent how similar they are. And this is a quick recap of last time we do we talk about ANN is we not search every single points in the space. We search by region so that it is faster and cost lower. And here it's introduced what has AI vector search. Basically, you can directly using what has AI vector search. It's a Google product. And in the specific way, you have to save in the JSON file, and you have to have index. And once you have index, you have to deploy your index. So those are just the steps you need to follow if you're using BigQuery. And eventually, you want to run the query. You generate the embedding of the query. Say how to read JSON with Python. That is a question. Before we type in the text box, we ask how to read JSON with Python, and we have all the result generated. So this is a text information. Again, we are trying to get the embedding of this text information with this numeric representation. Oh, sorry, Mumu have a question. Is this series going to focus on RAG and vector search, or are going to touch other related to AI LLM? Yeah, so this series is just going to be on RAG and vector search with some real life example. And I am definitely going to talk about other subject related to AI, LLM. So next one, I want to talk about some basic concept with AI agent. If you're interested in any topic, you can let me know so that I can prepare the related content. So the goal for the session is I want to try to study with you and share as I learn about AI so that we can overcome this AI panic together. So if you have any topic that you want to learn more, we can deep dive together. And also the session is meant to be beginner friendly, because I find a lot of tutorial that they assume that you already have the basic foundation already, and sometimes it's very frustrating to get started. So that's why I really want to have the session, so that I hope this is easier for you to start. Yeah. Thank you for the support. I'm going to come back to this example. And so when we run the query, we get the embedding from this question. And here we are able to get the result. The find neighbor basically is you're trying to find a neighbor of that embedding in the embedding space. So that's how you get a response. So maybe I can share my slide again on my computer. Okay. So this is last week's slide. I'm gonna revisit here this example. So previously what we saw is we have this embedding space with all the Stack Overflow question, and this is not the shoes here in this case is a question how to parse JSON file or any other questions, and then you search in this space. And in this example is we are using BigQuery to store the data, and we're trying to find a result here. Yeah. I also have it run in my space if you want to do it together with me. Or if you're interested, you can do it yourself, or we can do it together. Oh, okay, I'm sharing the wrong screen. So I basically run the whole example I mentioned in this Colab. So it's gonna take a while, but I can run it and just so you can see how does it look like. And in this example, you need to create a project on Google Cloud. So, and also you need to put the project ID here and do some config with a role, like as instructed. So I just create a brand new Google Cloud project and put the ID here, do the authentication, and then it's trying to load the BQ table into Pandas data frame. Again, the data set is the Stack Overflow. And so, yeah, I'm just trying to work through it while we're running because it took a long time. So here you have to authorize it. So once you authorize it, we load the BQ table to Pandas frame. This is similar to previous example with QuadGiant, but instead we are doing we're using BigQuery. And this is also similar to previously with the sentence transformer, but instead we're using the text embedding model. Forgot a comma. Valid syntax. What is a syntax error? This for E. Interesting. Let me see. Q. I don't think so. But E. Is there something wrong with my press? Did I miss any step here? I don't think I have missing. Interesting. For those of you who are watching, any of you have idea of what's wrong? The 7. Oh. Oh, wow. Thank you. Thank you. Thank you, Victoria. It's really helpful. Thank you for helping me debug. I completely ignore half a typo here. And it's probably gonna take like a minute to get the embedding for the question title and put them as embedding column. How about I share screen about the concept as I'm running this? Maybe I can share my window so I can switch to tab easily. Okay. So we're just let you know this. We're generate the embedding already. And we're loading. Okay, trying to get. Yeah. We're get embedding for the question, and here we're trying to look at the embedding similarity. I guess, yeah, I'm waiting for get embedding for the question, add them to the data frame. And next we're trying to get the embedding. Thank you, Victoria. Let me see. Yeah, it's 56%. And then drink some water, take some break. I wonder what you guys do when you're trying to wait for a build at your work or do your project. You're running something and you're trying to waiting for it complete. And what do you usually do? Like drink water, drink tea, step out. Gonna take a while. I'm gonna continue reading this. I think with vector AI, vector search, you don't have to do. So when we say ANN, approximate nearest neighbor, it's faster because it only search a region of it, and you're not searching every single of it. So it saves time and reduce cost. And if you're using this like as example, like in this BigQuery setup here, you're automatically doing this to save time. You don't have to understand how to implement them or how to use them because the tool already implement for you. That's my understanding. Victoria said tea and coffee are essential items. Yes, we finally got this. We have all the embedding for the embedding column. So you can see that here we have this embedding. I guess I cannot visualize the right, but you can see we have the embedding for each title here. Have this merge row based on the specific date. We have this embedding, and how we are basically generate this with the text embedding model here. And I'm trying to find a similarity now. Again, we're trying to, so in this example, we're using the dot product. So there are different ways you can do distance, you can do cosine, you can do dot product. And you're trying to find the similarity for the first 5 questions. So this is basically we're trying to find the top K similar result. So corresponding to this slide is we're using ANN, and then we're trying to find the top, like the 5 points that's close to this item using dot product. So that's what we're doing here. And then we print the question. Save ID and embedding in the JSON. I think those are just steps we need to do for this is for the storage API, creating the, so we need to create an index and then create index endpoint and deploy the endpoint so that we are able to do the query. So all those are just steps that I'm following the WordPress AI vector search tutorial. As you can see that previously when we do the one example, you don't have to do this example. Those steps, you just need to use CoreJoin client. But that's more like a lightweight. If you have like just CSV, you have small data, size data, and I think that's easier if you're using that library. But this example is more, with this solution, I guess it's more scalable and better, easy maintaining if you're doing production work. So now I'm create this index endpoint. I'm trying to deploy the index to the index endpoint. I don't know how long it takes to deploy. Let me see. To deploy, if it's the first time, it takes 25 minutes. But don't worry, this is the first time. After the first deployment, you finish in seconds. I hope we can finish soon. If you're gonna take 25 minutes, I'm not gonna continue run this. I'm not sure how long you're gonna take because last time I ran this, I also cleaned up, so I kind of deleting the endpoint already. So even though this is not my first time, maybe because I already do the cleanup, so it might actually gonna take another 25 minutes. But yeah, I'm not gonna run it here, but you can see basically once we deploy we create the index, we create the index endpoint, we deploy the index to index endpoint, and you're able to just ask questions here, like how to read JSON with Python, and then you're able to see the result here with the nearest neighbor. And here you can see the distance. Yeah, again, we are, yeah, I guess I shouldn't have deleted I did the cleanup yesterday, so yeah, I guess this is counted as a first time deployment. You're gonna take like half an hour-ish to deploy it. But once you deploy it, and you don't do cleanup, I think it's going to be relatively faster. But yeah, here, this is just this is the walkthrough of how we do it for the demo. I'm trying to look for the demo. Here's a demo. Okay, here's a demo. Yes. I think it's this demo. Again, I'm gonna put this link to the chat. You can try this demo. So you have the Stack Overflow question, and how to pass JSON. You ask a question, pass string to JSON, pass JSON response. So you can see we have results, and it's go to Stack Overflow. So this is how we implement behind the scene. We have the Stack Overflow data set, and we are getting the embedding for each question, and also we get embedding for this. We get embedding for each title of the each question for the Stack Overflow, and we also get embedding for this query question. And then behind the scene in this example is we're using this embedding text embedding model, and get all the embedding, and then we're trying to search this dot product for the similarity. Okay, it's too many code. I couldn't find a dot product, but yeah, you got what I mean. Oh, okay, similarity here is a dot product. Yeah, you're using the dot product to find a similarity, and then you try to get, you put everything to, with BigQuery, you generate index endpoint, and you deploy your index to index endpoint so that you have everything deployed, and now you just need to search. So that's another way of doing RAG with different tool. But yeah, today is just some, I guess it's still trying to deploy. Oh, for my DF, yeah, you walk around, build walk. Is that a habit? Like every time build something, you drink some tea, walk around, waiting whole day for the build running. Yeah. Anyway, so this is an example of two examples. So to recap, we have an example of a wine information. So that example, let me see if I can open it. Okay. Here. Yeah. So this is a wine example. In this example, we're using it's like relatively straightforward. We're just using Quadrant client transformer with pandas to read the data, and we just generate the embedding from this transformer and this Quadrant to do the vector search. And we also go to another example, which is a relatively complicated, that is using Vertex AI model to get embedding, and with BigQuery to do the index and then to do the search. So I hope that with those examples, you have more in-depth understanding of what, like, how does RAG work? So so quick recap. So we go through we went through two model to generate embedding, and we took a look at how we do the vector search in the embedding space to actually find a key similar result of it. And so we have these two examples. Yeah, again, if you are, I'm not sure if you're coming from my newsletter or just YouTube algorithm, but if you come from my newsletter or if you're already in the Discord, I will send today's application. I'll send today's example, so you can actually try run it in your when you have time, and I will send more tutorial to you through email. I'm trying to put them to the blog post so that it's easier to read. So that it's easier to read rather than just reading the slide. Because I feel like, okay, if you're reading the slide, if you're not watching the live, you probably don't understand what's going on. But so that's why I'm trying to put everything in writing and send it to you, so that if you're missing the live, you can just read the blog. So make sure if you're not in the newsletter, if you're not receiving newsletter, you can also ask me. I can send you the newsletter. Yeah, so that's pretty much today's content. And so next week, I plan to talk about AI agent. What does it mean of AI agent? What are some different tools? And actually go through different example of how do you build an AI agent, how do you write tools, how does the tool work, things like that. And of course, like Mumu previously said, am I going to touch other subjects like AI, LLM? Of course, I will do. So I will plan them and share the content with you. But yeah, the thing is, I will be here every Sunday and share all the content and share like learning together. So yeah, if you have anything that you want to explore together, you want to study together, you can let me know here, or you can let me know in Discord, or you can email me. Yeah. Thank you so much, everyone. I really appreciate each of you who come into the session. Thank you, Linux, for coming again. Thank you for my DF coming again. Thank you, Victoria, for helping me debugging. Oh, Roddy, I missed your message. A RAG and vector search session. Yeah, I will definitely create. So my plan is, I'm writing the content, and then I want to make like a short video so that you're able to understand a concept by watching like a 1-2 minute video. But I'm making them right now. So yeah, let me know anything you're interested in. Thanks, Dak, for coming. Thank you for coming again. Thank you, Victoria. Take care. Happy holiday. It's the end of the year. I hope I can see each of you next year. It's fun to studying together. AI agent session. Yes, next week I will talk about AI agent, because I actually did a AI agent workshop this. Oh, I have the written content here if you're interested. Let me share the link. Yeah. So Roddy, if you're interested in the AI agent content, I have some writing about. Let me share my screen. So I share you a link. So this is from a workshop done this year. It's AI image agent, and it's talking about function calling. Basically, you're able to try this agent by clicking this repo. Yeah. if you're interested in play around yourself or trying to understand, you're trying to study by yourself, you can read this article. But again, because the session, I want to make it more beginner friendly. So I want to talk more like basic concept, like what is tools, what is how do you build a simple AI agent, and how is AI agent different from RAG, and how you can doing information retrieval like RAG in AI agent. I think those are really interesting area to explore. Yeah. Thank you so much for coming, everyone. I'm gonna stay here for like a couple minutes in case you have any questions, and drink some coffee. Homework assignment. Yeah, if you want, you can try run it yourself. Like we have a very simple example here today with wine, and I can share that with you through email. And once you receive it, make sure you run it yourself. And you can share the update with me next week. What do you think, Victoria? Oh, sure. And also, yeah, if you're in Discord, you can also like share your updates in Discord. I will, yeah, we can connect. Yeah, thank you. Thank you so much for helping me debug, Victoria. You saved my day. Thank you. Yeah, I'm trying to figure out a way to share the notebook. Maybe I'll just share the notebook link. Yeah, I'm trying to share the notebook so that you can create a copy. So I'm trying to generate a link that you just directly create a copy of it. So that we can all run the playbook at the same time. Happy New Year, Victoria. Okay, figured. So I shared the notebook link in under AI section, like resource section of AI. If you join Discord, you're able to see there's a resource. I just put it there, so you can download today's notebook and data and play around yourself. And let me know how it works. If you run into any problem, you can ask. I'll be there. Okay. Thank you, everyone. Hope you have enjoy your holiday. And let me turn off the music. Enjoy your holiday. Happy learning. And yeah, look forward to seeing you next week. New Year. Next week, New Year. It's fast. Bye.